Okay, a bit more then on ASFurther, some complex numbers, and we're looking for loci now in the complex plane and how that looks. I'm not going to spend too long running through this wee bit here, but there's three wee techniques that we need to learn, and we need to be able to draw the locus then of these. So we're just going to run through the examples, and hopefully that will clear most of the stuff that you need to know up. First I want to sketch a locus of z whenever z equals 5. So that's the modulus of z equals 5, sorry. So we can think of a couple of places where z equals 5, where the length of the line would be 5. Here are our axes. The 0.50, for example, the size of that complex number is 5. What about the 0.5i minus 5? And then minus 5i would be down here then as well. So you can kind of see those points. Any other ones? You probably know 3 squared plus 4 squared gives us 5 squared. So anything with the 0.34 would be on it. So kind of 3, 4. So 3 across, 4 up. Sorry, let me get this right. 3 across, 4 up is going to be round about here. 4 across, 3 up. And you can hopefully start to see this thing take shape. The deal is it's going to give us a circle. So we need to try and draw a circle. It's going to be easier said than done. And that's our locus of where any point where the modulus of z equals 5. The radius of our circle then is going to be 5, and that's our locus. That's the first one. If you get any question like that, if you get modulus of z equals 3, you draw a circle of radius 3. Modulus of z equals 10, you draw a circle of radius 10. Example 2 is quite similar actually, but there's just this different center. So sketch a locus of z given that z minus 2 plus 5i equals 3. We need to rewrite this, and again it's just a wee technique to learn. And so 2 minus 5i equals 3. And so hopefully you can see I've just kind of written the same thing there. If I was to multiply out the brackets, we would end up then with that. And this gives us a center of the circle. This gives us the radius of the circle, and it's the same as the ones above. That's the way technique then that you need to learn. So that's the 0.2 minus 5. Now it only works whenever I get the minus here. It has to be z minus that. And if you take a wee read through up, actually in the notes here, it's z minus a here, and that's what that looks like in the Argand diagram. So let's draw ourselves in one of these. So that's the 0.2 minus 5. Which is down here. Now because that's 2 and because that distance is 5, I'm expecting the circle to cross this line here, and I'm not expecting the circle to cross this line here. So please, I mean, have a vague degree of accuracy whenever you're doing these things, as bad as the circle tends to look. But we'd end up then with something like that, where that's the 0.2 minus 5. Again, remember that's our real axis there. And that's our imaginary axis. So that's the first one you need to be able to do. Whenever the modulus of something equals that, then it generally looks like a circle. Let's take a wee look at the ones over the page. Sketch the locus whenever the argument of z then is pi over 4. So you can see that. Sketch the locus of z whenever the argument of z is pi over 4. Again, think of any ones where it's going to be 45 degrees. 1 plus I, 1 across 1 up, 2 across 2 up, 3 across 3 up, and we're just going to draw those in. So here's my axis again. That's my real axis, and that's the imaginary axis. Pick some of those points. There's a point there, there's a point there, 2, 2, 3, 3, 4, 4, and so it's effectively this line here, where this then is pi over 4. Now please note, it's not like coordinate geometry where this line goes on forever. It's known as a half line here. It just goes from here to here. This bit, the argument isn't pi over 4 down here. That would be minus 3/4 pi if you think about it. So it's only going to be up for this bit here. So sketch the locus of any complex number effectively where the argument is pi over 4. The locus then is going to look like that. Let's take a wee look then at example 4. Similar actually to our example 2 with the circle bit. Sketch the locus of z whenever argument of z equals minus pi over 6. So minus pi over 6 is effectively minus 30 degrees. So it's going to be heading down that way there. And it's a similar thing to what we did before. So we need to set this argument of z minus and then minus 3. That's where the line starts from. It's the point minus 3. So let's draw this in. Minus 3, 0, and then minus pi over 6. it's going to go down then like that, where that way angle then is pi over 6. Again, it's just a half line, so it goes this way here, but it doesn't go this way here, and that's the point then minus 3, 0. That's your imaginary axis, and that's your real axis. That's what we're looking at from that one. Okay, so that's that one and that one. The final one we need to be able to do, and it looks kind of similar to the first one, but it is different, is sketch a locus of z such that modulus of z plus 2 equals the modulus of z minus 1. Again, we're going to rewrite these, so it's going to be modulus of z minus 2 is equal to z minus, and then that's going to be I there, and we effectively plot those 2 points first of all, and I'll explain what happens then after that. So you might have, I mean, it could be, you know, like a 2 plus 3i, in which case, you know, you do the same in the previous examples. You would take that point out, and that gives us our starting point. So the point minus 2 is going to be here, and then the point I is going to be here, and here's the line that you need to get. We need to draw the perpendicular bisector of these 2 points. So you join them up like that, and we're going to draw a line then going down at 90 degrees through the center of those. That's not too bad, and that then is the locus then that we're looking for. That's a point minus 2, and then that's I up there, and that's what we have. So let's go a quick reminder of the 3 different techniques then that you need for that, and we'll see then from there. You will get 3 different types. The first one looks like this or like this, and it will give you a circle. If there's nothing there, the circle is at 0, 0 center. Here you need to take it out like this, and the point 2 minus 5i then represents the center of your circle, and go then from that. The second one then will give you the half line. If you're given argument of z is pi over 4, argument of z is minus pi over 6. Again, the set excuse me, where the line starts from will be given in here. There's nothing there, so it starts at 0, 0, half line going at pi over 4. Here then we have our half line going then at minus pi over 6. And the final one that you need to be able to do is one that's in this form here. If we have that, again, this is where you represent these 2 points here, and we're looking for the perpendicular bisector then of those 2 points.